Okay. So let me do a little motivation here. If we had 80 people, I want to know the probability that I get exactly 10 left-handers. We can set up part of this, hopefully. Right? What would this P to the what, Q to the what would that part? And we just got to talk about what number goes here. I don't want to put this list together. Can you imagine this list? 80 spots. Maybe the first 10, or the last 10, or the first 2, and the middle 8, and the last, that's insane. I don't want to put the list together. But what is this definitely going to look like? How many left-handers do I want?
10.
So how many successes do I want? 10. How many failures do I want then? 70. Good. So these two always do what?
Add up
to how many things you're looking at. Does that make sense? Because it's exactly split between success. Either you're a success or you're a failure. You're what I'm looking for or you're not what I'm looking for. You can't be in the middle, right? That's kind of freaky. So all we need, so I know if I put 0.11 there and 0.89 there, I'm part of the way there. I just need to know what number goes here.
Is it 80? 10.
No, it's not.
Why?
It's stupid big. Right? I really want you to realize, just start to think.
It's all the possibilities, right?
It's all the possibilities, exactly. But it's going to be a lot bigger than you think.
Oh, it's 10 to the 80, right?
No. It's not going to quite be that big. That's. I think it's more than all the atoms in the universe. So, not quite that big. So here's the idea. All right. So in the book, they're going to show you a formula with an exclamation point. Does anybody know what mathematically that means?
Factorial.
What's the matter? You all right? Yeah. I love that back row. They're like, you sit back there. You're not going to get the chances. So 6 factorial. Good. So that means factorial. So what does that actually mean as an operation?
5 times.
Good. So if you've never seen this before, this is what this means. So 80 factorial would be 80 times 79 times 78 all the way down to 1.
Oh, we would put 80 factorial there? No.
Not quite.
Of course not.
No, not quite.
That would be too easy.
That would be too easy. So there's a formula in the book. Okay, this is the formula you're going to see in the book. We're going to use the calculator to do this. And the reason I do that is because there's really nothing to be gained by... There is a lot to be gained by this, but this is actually for a different course. This is a statistics course primarily that uses probability. This is not a probability course. So in a probability course, you would be doing this a hell of a lot. Oh my God. We only have one chapter probability, so I really don't want to take a lot of time talking about different ways to count things. Right? But really what this boils down to, in the calculator, this is going to look like this. I've got 80 things. I've got 80 spots, 80 people, and I want to choose 10 of them to be left-handed.
What is C? C10?
Yeah, so I just called it choose. In reality, it's called a combination. That's how many ways to combine. That's how many ways to do different combinations of 10 things using 80 things. There's also something called permutations, which have a P. So if you've done any probability stuff before, you might have seen permutations and combinations. I just want to do this one thing that we need. And remember, what's the thing that this really does? What does this really accomplish? What number was here? Why was that a 5? Because that's how many ways to choose one person out of 5. Right? It tells me how long this list would be. So if I have a mathematical way to figure out how long the list would be for this, choose 10 people from 80, then that's all I need. That's the number I want to put there. Right? So here's how you do it in the calculator. And the reason I put this up here is just so if you see it in the book, you'll know kind of what the factorial means, the exclamation mark. It doesn't mean like, but please, dear God, you do not have to do this when you calculate your probabilities. You don't have to do this formula. You just have to do what I'm about to show you. Is he really? No, he's fine. Oh, yeah, thank you. All right, focus. All right. So if I want to do 80, so put in there 80. That's a really cool thing. If you go to math, so 80 and then hit math. Which one do you think I want to go to?
Probably.
Yeah, dude. So go to PRB. And we don't want, and PR, we don't want National Public Radio, we want number 3. All right, so that's 80, choose, and they use the letter R, whereas we're going to use the letter X for our number of things we're choosing at a time. You with me? So that's just really showing me the full formula. So if you do 80, number 3 from this list, 10. This is how large that list would be. Right? That's 1.6, move the decimal point that way 12 times is the number you would be faced with. I don't want to make that list. Right? That's like the number of possible combinations of toppings on your pizza I was telling you about earlier. I mean, that number gets really stupid big really quick, much quicker than we might think. Now, I'm not going to put the whole damn number there. What I'm going to do is, help me fill out this formula here real quick. So this part will be 80, choose 10. That's going to be how long my list would be, representing all the ways to choose 10 people to be left-handed out of the 80 people that I've got. Is that cool? Because I know from experience, that's the number I want there. How long that list is going to be. And then what goes here? Yeah, 0.11 to the 10th, 0.89 to the 7th. So I got 80 people, choose 10 of them to be left-handed. So I've got 10 who are left-handed, 70 who aren't. Do you see how you can read that formula in English? Let's try to put that into the calculator. So if I do 80, math, probability, number 3, so there's 80, choose 10. Keep going, times. Because this part will get really big, even bigger than what we have here. And this part is going to get stupid small. So either of them on their own could actually freak your calculator out. But when you multiply them together, your calculator sometimes, not all the time, sometimes it's going to have an overflow error. But it'll be able to average them out. It'll come out to a nice normal number. So if I do it all at one time, I'll be a little bit better off. 80 choose 10 times 0.11. I hope I didn't pick a situation where it goes crazy. The 10th times 0.89 to the 70th. Oh, good. So about a 12% chance. That's kind of crazy. So if I just picked 80 people at random, the probability that exactly 10 of them are left-handed would be 12% chance. Okay, cool. And how many would I expect to be left-handed? Don't overthink this.
11%, right?
11% of?
80.
80. Yeah, 8.8, so about 9. I'd expect about 9. I really want this to come together. We just figured out the probability of exactly 10. How should the probability of 9 relate? Since it is the expected value, the probability of 9 should be the...
Mean.
Should it be larger or smaller than that probability? Since this is the average, this is the expected value, should this guy's probability be higher or lower than this?
Lower.
If it's what you expect to happen, should it happen more often or less often? So its probability should be higher. You guys with me? So the expected value in this case, for a binomial situation, the expected value, the mean, will be the most likely thing. Now you can understand where I came up with the number 10 then. I kind of did real quick in my head, just said it's somewhere near 10. Right? Just said 10% of 10, 100 is 10, so that's probably 10. I wanted it to come out to something wouldn't freak the calculator out. If I try to put the number 78 here, why might the calculator freak out? That probability would be really small. You're not going to have, what's the chance that I pick 80 people at random and 78 of them are left-handed? I mean, like, what, where am I? What's happening? You guys kind of with me? Tiny bit, okay? So sure enough, if I do this again, and if you hit second enter, it's going to be really a beautiful. Second enter is one of the most awesome things on this. So then you can just go back and change. I don't want 10. Let's make this 9. 0.11 to the 9th. And then what's 0.89 going to be to? 71. I like it. Why did you hit graph, Jeff? Oh, man. And obviously that probability is definitely larger than that. Now, if I did that with an 8 in it, it's going to be smaller again, probably close to that. It's probably going to, it's actually kind of nice. It's probably going to come out a little bit almost normal. It's going to be a little symmetric around 9. So if we do 8, just try it. Second enter, go make it an 8. So this will now be a 72. Not. Why is that higher, Jeff? I don't know. 0.11 to the 8.
Maybe this getting closer to like the actual probability of 0.11 or 1%.
No. Let me see. Oh, wasn't this? This came out to be 8.8.
Yeah.
So 9 should be the highest one. I don't like it when you go against theory. What's happening there? What did I do?
Try 7.
That's freaking me out.
Try 7, see if it goes down.
Well, 7's definitely going to go down.
But by how much?
I'll do it next time.
Yeah, okay. But 8 should not be the highest. 9 should be the highest. I appreciate that. Alright, I'll think about it. Something I played in wrong or something. Freaking me out. That's 8.8. That's crazy. Alright, I'll stop. But what should happen, and somewhere there's a mistake I made, is the probability of the mean should be the highest. Now the mean is actually 8.8, but the closest thing to that is 9. That should be the highest. Don't know why it's not working there. But you see how it is kind of symmetric. As we go around the mean, it's going to go up to it and then down from it. It's kind of nice. And when we get to section 6.6, we're going to see the connection between a normal distribution and a binomial distribution. It's going to be kind of cool. That's in our future. So one quick little problem, just using the formula, and then we'll head out. Let me give you guys a little setup and see if we can set up the formula. Let's say the probability somebody likes binomial probabilities. Let's say that's equal to 0.07. So if I pick, what do you got, Jeff? 38 people at random. What's the probability that exactly? Oh, what you got, Jeff? Exactly 3. What? So try to set up the formula. Try to plug it in your calculator. So how do you set this up? Oh, sorry. You guys see that point yet? This is a either you get it or you don't currently kind of situation. So if you don't quite get it yet, it's fine because we just barely start talking about it. But how do you set up the first part? Yeah, I got 38 people.
Times point.
Choose 3 of them.
Yeah.
Yeah, it's kind of nice how it repeats itself. You got 38 people. You want to choose 3 successes, so of course you got 3 successes. And then how many? And what do you put in here? Good, because these 2 have to add up to be the total number of people, because they fall into one of those 2 categories, right? So let's try it out. Let's see. 38. Choose 3. Where do you go? 0.07 to the third times 0.93 to the 35th. Alright, so 23% chance. So people freak out. Does everybody see relatively how easy that is to set up? All right. And people freak when they see the actual formula. So let me show you the formula. This is going to be n. It's going to always be the total number of things I'm working with, right? And I want to choose x of them. X is going to be my variable. Because how many successes could I have? Anywhere from none. You could have 0 successes up to n. So x is our variable here. It's the number of successes that I want. P to the x, because I want this many successes. And here's where people freak out. Q to the rest. What's left over? If I have n total and I use x of it here, n minus x. That idea of a total and then it's less by what you've used so far. That happens a lot in algebra. And it just happened to us again. But all that means is, whatever you put there, you put the rest there. That's what that formula is trying to tell you. But for some reason, that freaks people out.
So that's pretty much that.
That is that. This is the binomial probability formula.
But we don't need to know that because
Not for the quiz yet. But that is a future formula for your next test formula sheet. Do not put this on your quiz formula sheet. You'll freak yourself out. You're like, where am I using that? Nowhere. Not yet. Okay. That's all for me today. Enjoy that. Quiz on Wednesday. There's that.